Alright, this is lesson 3 in the scale factors and similarity unit for Math 9. We're looking at scale diagrams today. We're going to be analyzing them and learning how to understand them. Really important life skill because you'll see these in your everyday life, especially in like maps and also in building drawings for buildings and houses and things like that. Okay, so a scale drawing is, or a scale diagram is a two-dimensional drawing that represents an object, and it uses a scale to show how large the lengths are on the drawing compared to real life. Let's look at this example. This is a really common example. We use scale diagrams all the time to show how large rooms are in houses and buildings and things like that. Okay, so we have the scale drawing. This is like a top-down version or a top-down view of a bedroom. And we are using 1 centimeter grids paper, and we have the scale shown here. 3 centimeters is 1 meter. Question A, convert the scale to a 1 to blank ratio. Let's change them to the same units first of all. So it'd be 3 centimeters on the drawing is 100 centimeters in real life. If we're going to change this to a ratio that is 1, then we're going to need to divide this by 3. So that means we're going to need to divide this one by 3. 100 divided by 3 is 33.3 repeating, or about 1 to 33 if you round it off. Okay? So for every 1 centimeter in the picture, we have 33 centimeters in real life. What are the dimensions of Oscar's bedroom excluding the closet? So let's look at the length. Okay, I'm going to use highlighter so that we can read it. I'm going to erase this highlighter that I've already drawn here. So every time we have 3 centimeters, it's 1 meter. So that's 1 meter. And then we have another meter. And then we have another meter. And another meter. And then 2/3 of a meter at the end. So this is 1 meter, 1 meter, 1 meter, 1 meter, and then 2/3 of a meter. Okay, so the entire length of the bedroom would be 4 2/3 of a meter, or about, if you want to write it as decimal, 4.67 meters. That's the length of his bedroom. Now the width, let's do the same thing. You use a different color this time. So every time we have 3, it's 1 meter. So this is 1 meter. And then we have another meter, and then 1/3 of a meter at the end. So we're going to break it into groups of 3. There we go. So this is a 1 meter, 1 meter, and then this is 1/3 of a meter. Oh, sorry, you can't see that. I'm going to move this over just a little bit. Actually, I'm going to zoom out. There we go. Okay, great. So our width is 3 1/3 meters, or about, if you want to write it as decimal, 3.3 meters. Okay, C. How wide is the window? So let's look at the window. If we split it into groups of 3 again, 1, 2, 3, 1, 2, 3. So it is about 2 meters. 6 squares. And then finally D, the closet is, how deep is the closet? So if we look at the closet, it's 3 squares deep, so that means it is 1 meter deep. All right, great. Next question. Fill out the table below and use a more appropriate unit where necessary. Okay, so this is a good for just really understanding these scales and the scale diagram versus the actual distance. Important to remember for the scale is the first number is telling you the diagram or the drawing size, and then the second number is telling you the actual size. So for this first one, the actual size is going to be larger than the scale diagram size. So we're going to multiply by 4 here. So 7 millimeters times 4, the actual distance is going to be 28 millimeters. And that's a pretty appropriate unit, so we'll leave it as is. Okay, this time the diagram is larger than the actual size. So this time we're going to divide by 36 to get the actual size. 270 divided by 36 is 7.5 centimeters, and that's an appropriate unit. It's reasonable. Okay, this one, the diagram size is much smaller than the actual size. So if I'm going the other direction here, I'm going to divide by 2,000. 35 kilometers divided by 2,000 is 0.0175 kilometers. That doesn't seem very reasonable. I'm going to change that to meters. When I change it to meters, I'm going to multiply it by 1,000. So it's 17.5 meters. Okay, and last one, we're going to figure out the scale. So this time we're told the scale diagram distance, we're told the actual distance. In order to figure out the scale, we have to get them in the same units. So we want to write them both maybe in centimeters. So 2.6 millimeters is the same, or sorry, maybe we'll write them both in millimeters, it'll be easier. Yeah. So 130 centimeters, there's 10 millimeters in a centimeter, so that's the same as 1,300 millimeters. And if I want to figure out the scale, it'd be 1,300 to 2.6. And if I want to reduce that, I want to divide by 2.6. And so we'd get 500 to 1 as our scale. So the scale diagram is going to be 500 times larger than the actual item or object.